Hello, students. Looking at the homework for 7.1. 7.1, 3 through 8, 10 to 12. Let's see here. Looks like 10 to 35, and I've skipped 16 and 13. All right. I guess I've skipped 9, 13, and 16. And you go 3 to 35. Now, a lot of these are going to be very quick on purpose. Again, based on your knowledge of decimals, which for most students tends to be a little bit stronger than their work with fractions. Let's jump down here. All right, so basically 3 through 35. So again, write the answers, write the decimals as fractions, then write your final answer in decimal form. So you are going to see some like this, and the goal is to just kind of remember, why do we line things up? Always have a reason for your students. Let's see here. Some digits are covered by squares. Each of the digits 1 through 9 is used exactly once. Determine the smallest possible number. Now, there is a decimal point here. Where could I put the digits to get the smallest possible number? So I have to use each digit 1 through 9, kind of like a Sudoku. So 9, where would I want to put the 9 so I get the smallest number? Should I put it up here on the left? Should I put it over here on the right? Okay. Let's see here. These questions, number 5, yes, you can go through and line everything up. Please try to find ways that are a little bit more efficient. Example, 14.99. Yes, I could write out 14.99, but I could really just say that's 15 minus a penny and kind of keep my minus things going in a little column, which makes it very, very convenient at the end. And it might be significantly easier to work with. So I'm going to let you try that one, but please, if you're just doing the long addition way, it's going to seem tedious. That is not the goal. The goal is to make these very efficient and quick. Let's see here. Number 6 is probably a calculator question. Did I even read? Yeah, I said 3 through 8. So invested this much in 18 shares of stock. A month later, she sold them for this much per share. You can figure out how much total. She invested in 350 shares of another stock. For this much, she sold this stock for this much a share and paid this much in commissions. How much did she make or lose? Think about how much money she started with. Think about how much money she ended with in each case. Sometimes she might make money, sometimes she loses money. And at the end of the day, she did pay 495 in commissions. So that's going to drop down her total profit or loss. Let's see, your stock price dropped from this to this. What was the loss on a single share of stock? So again, a little subtraction there. If each of the following sequences is arithmetic or geometric, continue the pattern for 3 more terms, and they are arithmetic or geometric. Your goal is to figure out what is being added, subtracted, or in the case of the ratio, what is being multiplied or divided. Okay, so I said 3 through 8. I skipped 9. It was that magic square stuff. Not bad, kind of fun, but I know that not as critical. We'll do 10 through 12. I did skip 13. Write the following as fractions and multiply. Okay, so same thing that we did up there with addition. You're just doing multiplication now. And then find the least and greatest possible products for the expression using the digits 1 through 9. So you can put digits in any way you want. Notice the first number is a blank point blank. Each digit may be used only once in each case. All right, and let's see here. When you multiply a positive decimal less than 1 by a decimal greater than 1, will the result always be greater than 1? So interesting. This, to me, probably even could have been in the MCs. Okay, a positive decimal less than 1 by a decimal greater than 1. Think about that as you're trying to do it. Put in some example values and multiply. I said skip 13, not that it's bad, because it's the sum of a geometric sequence, and we really didn't focus on that back in chapter 1. 14, which of these result in equal quotients? This is the idea. You can take two things that are being divided, multiply them by the same value, and they become a new looking equation or a new looking expression, and you have to actually say which are the same. So for example, 20 divided by 5. If I multiplied each of these by 10, I would have 200 divided by 50. However, these would be equal quotients. They would get me the same answer. Okay. And the same thing is true if I came back up here and I multiplied by 2. So this became 40 divided by 10. Well, again, these are all equal quotients, right? But if I was to just do that to one of them, what about 200 divided by 5? Well, wait a minute. 20 divided by 5 is not the same as 200 divided by 5. So the others are the same. This one at the end is not. Well, let's see here. They're building a scale model. That goes back to chapter 4. What is the height of the model? You may need decimals along the way here. And let's see here. What else do we have? 14, 15. Okay, so I said skip 16. Skip that. That's kind of an interesting one. That to predict how tall a 4-year-old will be at age 12, you multiply their height by 1.5. Okay, you're welcome to do that. I don't think it's necessarily that accurate, but and then we move on. The value of yen in February 2018 was given by this equation. What is the value of $200? So $200 into yen, you could use proportions for this. But because you'll be multiplying by decimal numbers, that's why it's in this section. Same thing here, 7,000 yen, but you know this many yen is $1, but with the price in US dollars. Okay. There's my speed in miles per hour. How far did it drive in 3 hours? Now we're going to be multiplying a fraction and a decimal number together. Not really a huge issue here. Let's see here. Number 19 is kind of a good one. Might even think of it more as kind of an algebra type question. 30 pounds of nuts at $3 a pound, 20 pounds at $5 a pound. They want to buy 10 more pounds so that the average price per pound is equal to $4.50. What price should he pay for the additional 10 pounds? So now be thinking at the end of the day, how many total pounds, right? And how much total money has he spent? If you think about it that way, you could actually use this average price near the end of the day to come back and say, okay, I know exactly how much he needs to pay for those additional 10 pounds. Okay. Let's see here. Conversions. $1 is this many Canadian. What was the value of this many dollars in Canadian dollars that day? So again, how do we use conversion factors? Let's see here. Kind of ratios, but ratios that involve decimals. So you're going to be doing division with decimals, and this is where you can base things on the cost per ounce. Sometimes you see that at the grocery store. And let's see here, this many liters of milk from each of his cows. He milks all 5 cows, pours the milk equally into half-liter bottles. How many half-liter bottles can he fill? Wow. You've got multiplication with decimals, then you've got division with decimals. That might as well be fractions. This right here is basically a fraction problem, right? Yeah, basically. All right, let's see here. Juliet has so much candy. She puts the candy into 9 jars. How much candy in each jar? This is division. And whole number division, the answer was a whole number. Now the answer may not be a whole number. But you might get a decimal number and you have to round up or down accordingly. Okay, so what you have to do during these problems is go through, read the problem, find the solution to the problem, and then think, should I round up or down? So if they're asking how many cars do I need to take somewhere, and it comes up with 4.6 cars, right? 4.6, you can't take 0.6 cars. So 4.6 cars would be, you need to take 5 cars. If you tried taking 4 cars, you would leave some people behind, and we don't want to leave people behind. Okay. Let's see here near the end, you've got question 25 and then some additional questions on scientific notation. Put it into scientific notation, take it out of scientific notation. 27, 28. How far did I say to go? 35. Okay. Yep. Scientific notation. Write the following in standard form. Write them in scientific notation. And write the results of each of the following in scientific notation. So again, you get to practice a little bit with your exponent rules as well. When I multiply with the same base, what do I do with the exponents? Okay. Let's see, where would that be? That'd be back in chapter 3. But we also covered it again in chapter 6 and chapter 5. Yeah. So 3, 5, and 6 is where we talk about those properties. Let's see here. Multiply each number by 0.001 using mental computation. Think about what it means, right? What is 0.001 as a fraction? That might help to show you how to kind of do that. This one says mentally compute her salary. Multiply 40 hours a week by $6.25 an hour. That is not good, right? That wage is not, that's not going to be good. That's below pretty bad minimum wage. But you could still do the process, especially when you think about the 0.25 being 1/4. of a dollar. Mentally compute, and this is the idea of rewriting multiplication so that you get the same result, rewriting division so you get the same result to form a new quotient, form a new product. And then you rounding. 33 is all about rounding. 35 is about estimation, and 34 is about estimation. Those are two about estimation. And you can kind of say, where would it be? If I put 0.3 plus 0.31, where would that be on a number line? And 0.3 minus 0.31, where would that be on the number line? All right. Well, that does it for the homework part. Again, doing addition, subtraction, multiplication, division with decimals, treat them and think of them as fractions because they are. And don't forget, fractions are our friends. All right, off you go.